Hello everyone, today let's solve the problem number 212, word search 2, right? So we have already solved word search, right? So today we'll be solving word search 2. So what the question states here, we are given a 2D character board. You can clearly see here we are given a 2D character board, right? So and a list of words. So here you can clearly see we are given a 2D character board as well as the list of words. Words equals oath, pee, eat and train they have given here, right? These are the list of words. We have to return all the words that can be formed by sequentially adjacent letters. This is very important. Just hear this again, sorry. We have to return all the words that can be formed by sequentially adjacent letters, right? So either we can move up one step, down one step, left or right one step without reusing any cell. So we shouldn't be using the same cell again, right? So without reusing any cell they have mentioned here. We have to return all the words that can be found by sequentially adjacent letters up, down, left or right without reusing any cell. This is very important, right? I hope this is completely clear, easy to understand, right? So let's come to the first example here. Just give me a second here. So this is the board we have, right? So here we have been given all the words and this one, yeah, all the words that is present in the board, right? So we have to check whether these words exist in the board or not accordingly with the requirement. Means we have to find all the words that can be found by sequentially adjacent letters without reusing the cell, right? So in this case, first we will start from 0, 0, this one, right? 0, 0. So we have found a o here, right? We have the word oath basically. Next we will go right. We have found a, so this is fine. Next we will move down. We have found t, and next we will move down one step and we have found h. So we have successfully found the word oath here, right? By moving one step, this one, right, down and again down, right? One step at a time. So we have successfully found the oath. So we will return the same thing in the form of output. Just give me a second here. So we will return oath here. This is fine. We have successfully found the oath. This is fine. Next, so we will go with first. We'll start with E here. This one. So this is basically this one 1 comma 3 right here. This one 1 comma 3. We'll start from E here. This cell and we will move one step left. We found A here. We will move one step left again. We have found T. Basically, we have found eat as well. Eat and oath we have found in the this one grid, in this particular grid, right? So we will return both eat and grid. So next let's check for P here. So P is not present in the cell at this one grid at all. P, the letter P itself is not found in the grid at all. So will not return this one, right? So we shouldn't be returning this one. So let's check for rain. So rain, RAIN is present, no doubt. RAIN is present. But what is the requirement or what they have given in the question basically? We have to find all the words that can be found by sequentially adjacent letters, right? So is there any adjacent letter A here to the R? So here you can find K is there and V is there and E is there. A is not present at all. And we will check whether one more R is present in the grid. No, right? So in this case it miserably fails. So rain could not be formed because A is not found adjacent to it, right? Either up, either left, there is no this thing right at all, and even down. So A is not present at all, right? And there is only one R that is present in the grid in this case. So this also fails miserably. This we shouldn't be returning this one as well. So oath and eat are the words that we should return in this case. So that's what they have given in the output as well, right? Same goes with the example 2 as well. I insist you to try out in the same way, right? So I'll just explain quickly. That's fine. A, B, C and D we have. So the words we have is A, B, C, B, right? So here by looking at this itself you can say we have here only one B, but in the words we have two B's that need to be found, right? We have two B's that need to be found. We don't have two B's in the grid. We have only one B in the grid. So this is not possible. This fails miserably. In that case, we have to return empty array as the output, right? So simple to understand, right? So this is fine. So I hope the question is completely clear, and what we need to do is completely clear as well, right? First, let's discuss the approach, followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the. So first thing that we need to note down here is we will be going with the try plus DFS, right? So we'll be going with the approach try plus DFS along with the backtracking. Mainly we are going with try plus DFS. Just keep this in mind, right? Along with the backtracking. So I have considered the same first example that they have given in the question, right? So we have already discussed this one. We saw this one, right? Both P, eat and rain. Basically, P and rain. We couldn't find P and rain in the grid accordingly with the requirement that they have given in the question. So we had returned oath and eat. The first example we have already discussed this one. This is fine. Let's move on with the step-by-step execution here, right? So this is the grid they have given for the example one. So the first step is we will build a try with all the words. Basically, what we will do, we will build a try with all the words. In this case, so when we build a try, root node will be there. Here first is this one, oath, basically OA T H. So this is the try. The second word here is this one, P E A. Same goes with the other two words as well here. So I'll not be writing. I have just said same goes with other two words as well in this case. So we successfully built a try for the fast prefix checking, right? So we will start DFS from every cell. We will begin from the cell 00, which is O, basically, which is O, means which starts with O, basically. Now we will start the DFS from O, right? So after visiting this cell, we will mark this cell as visited, right? So we have found O. Next we will check for A, right? Next we have to check for A. So let me do one thing. Let's check one by one within the try. So I'll just give here, just give me a second here. In this case, we are going with oath right here. So here in this case, this is root node, root try. So first let's check for word oath here, OA T H. So this is fine, right? First we have found O. We'll mark this cell as visited. Next we'll move right. We have found A. We'll mark this cell as visited, basically. Next, so we'll come down. So we have found T. Then we'll mark this cell as visited. Then we'll come down one step and we have found H. We'll mark this cell as visited, basically. We have found all the letters for this particular word they have given in the word OATH, right? So we will return oath. We have successfully found. So I'll just write here oath. This is fine. So next, let's come to the this one. So here we did the same thing. O exists in the try. Proceed to its neighbors. So next letter A is present at 0.1. We did the same thing here. We saw that one. Next T was present at 1.1, 1,1. Sorry, we continued. So next H at 2,1. We found full word. So we will return oath. We will add this one oath to the result, right? So next we will continue DFS for the other parts and we'll find the eat similarly. Let's come to this part, basically. So we have successfully found the oath. Let me check for the next word that they have given here as this one. What do we call? P. Let's check for P here. So here in the try we'll be having P E A. But you can see here in the try we have already stored P, but the letter P is not found in the grid at all. The letter P itself is not found in the grid at all. So this miserably fails. Will not be adding the P to the result. Only oath is there. It will remain as it is, right? So let me delete this one. So next let's come to the next word here. So in this case, let's go for the eat now. So here eat means first we have already stored eat in the try, right? So this is it. So first we will start from 1 comma 3 here. We have found E successfully. So next we will check for the left cell. So we have found A successfully, then we will check for the left cell, and we have found the T successfully, right? Left, one step left, we have found T successfully as well. So we have found all the letters in the grid accordingly with the requirement. So along with the oath, we will be adding the E to the result, right? We will be adding E to the result. I hope this is clear. Let me delete this one. Let me come to the final word that they have given in the question. So I'll just come here in this case. So we have to check for rain here. So we have already discussed this one, rain. So here root node. So this is fine. R A. So just give me a second here. 1 second. So yeah, I'll just give here R A I N. This is fine. So now we have stored rain in the try. So we'll check for we'll start with 2 comma 3 because we have only one R in the grid. So we will check every possible combination. Means we'll perform DFS. We'll check for A is not present left. We'll check for A up, A is not present. We'll check for A down, A is not present. We can go either horizontally or vertically. We cannot go diagonally when performing DFS, right? That to one step only. So right, there is no cell at all at the right. So A is not present, and then there is only one R in the grid. So we have RAIN in the grid, but accordingly with the requirement, we have to find only the sequentially adjacent letters, right? That forms the particular word. Here, this fails miserably as well. So we'll not be adding this one to the result as well. So the among the words, 4 words that they have given in the this one words array, so we have found only 2 words basically that can be added to the result. One is oath and another one is eat here in this case, right? So that's what we have added here, oath and eat. I hope this is clear, right? So I'll just come here. So we will continue the DFS for other parts and eat and find eat similarly. So we have find oath and eat, this one, oath and eat, right? So words like P and rain are not reachable and they'll not be added in the result, or they are not present in the result, right? Or they'll not be added to the result. So the final result that we got here is this one, eat and oath basically, right? Eat and oath. The output that we got here is eat and oath, which is equivalent to the output that they have given for the example 1 in the question, eat and oath here, right? So our approach works absolutely correct in this case. So we went with the try plus DFS along with the backtracking. So our approach works absolutely correct in this case. As we are familiar with the approach, let's discuss the edge cases very quickly in this case. So let's come to the first edge case here. So the first edge case here is for the word not reachable. The first edge case is for word not reachable. So words we have been given A, B, C, and board has no A. So and we have considered board has no A here in this case. So board has no A at all. Only one word they have asked us to find, that is ABC, and they have strictly mentioned here board has no A. So output has to be null in this. I mean empty array in this case, because board board is not having A at all. Sorry, in this case. So we'll be returning empty array in this case. Let's go with the second edge case here. This is for the condition word with the same reuse. Word with the same letter reuse. In this case, we have A twice, right? A twice. So words we have to find here as A. One more word, one more A has to be present in the board, which is not present basically. So in this case also we will display this one, empty array, as output, right? So let's go with the third edge case here, multiple words sharing prefix. When I say multiple word sharing prefix, words we are going with is oath and oak here in this case. Oath and oak is present in the this one as well, board. Let's consider board, which consists of basically this one, oath and so this one. Just consider for the example sake, it consists of O and oak, right? Just consider this one. So oath and oak are present in the this one board as well. The words that they have asked, oath and oak, that is present in the board. So output, what we'll do, we'll just display oath and oak. as they are present, right? So this is fine. So the next thing here is the final edge cases for the empty board and words list. So both the board and words is empty. In this case, we have to return the output empty array itself, right? So these are the edge cases that we need to keep in mind. So the first edge case is for the word not reachable. The second edge case is for the word with same letter reuse. The third edge case is for the multiple word sharing prefix. The fourth edge case is for empty board words list. I hope these edge cases are completely clear, right? So we are completely familiar with the approach as well as edge cases. As we are completely familiar with the approach and edge cases, we are good to write the code. Let's start writing the code. So now let's start writing the code. The first thing is, we know that each try node can have 26 children. Means I'm speaking of 26 letters A to Z, right? So each try node can have 26 children. So let's do one thing. I'll just consider here try node. So let me go with the variable name children here. Let me create new try node of 26 because each try node can have 26 children, basically from A to Z, right? So the next step here is we have to store the full word at the end of at the end node. Means we are storing the full word at the end node itself, right? So this one we can articulate this one in the form of code in this way: string word equals, let's assign this one to the null initially. This is fine. So let's come to the this one, find words function. Within the find words, what we'll do first, we have to display the final result list, right? So I'll just go with here list string. So we'll be making use of the array list, right? So I'll just give, sorry, this one variable name I'll consider the result. Let's create the array list here, new array list. This is fine. So the next step here, we have to build a tray from the words list. So I showed this one by considering each example, I mean each word, by considering the each word that they have given in the words array, right? So we saw this one step by step. So we have to build a tray from the words list first, right? So let me consider here try node root here in this case. This will be build tree of words. Build tree of words. This is fine. So next step, let's go with the iteration. So I'll just quickly write this: int rows equals board length of the board, basically length of the board, and columns equals, we are initializing rows and columns first. So this one will be border 0 dot length. This is fine. As I have said, we'll be going with the iteration. We have to iterate to the rows and columns, right? So I'll just give here in this case int r equals 0, r less than rows. This is fine. R less plus. So this is fine. Next, let's go with the columns. So this will be int c equals 0. So let me do one thing here. C less than columns here. Let's increment the C. This is fine. So the next step is here we will check if the current letter is start of any word, right? So current letter is start of any word. Within the grid, we have to check if the current letter is start of any word. In our case, for oath, it started from 0, 0 itself, right? O. So that's what we'll be doing here. We will check if the current letter is start of any word or not. That itself we have to this one implement in the form of code. If we have found the start letter, then we have to go with the DFS search next, right? Or then we have to perform DFS, right? So that's what. Let's write that one in the form of code here. If root dot children here in this case of board of R C, this one hyphen A, because it consists of the 26 letters here. So this is fine. Index of that particular letter, basically. So if this is not equal to null, then if we have found the starting letter, if it matches, then we have to perform the DFS search. So let's go with the DFS. So to perform the DFS search, here we'll be making use of the helper function DFS basically, right? So I have written the DFS function here. Let's first write the another function, DFS function, and then we'll be making use of the same function within the main function. Main function means find words function. This one I'm speaking of, find words function, right? So just give me a second here. So I'll just come out of this function entirely. So what I'll do, let's write the DFS function first. So I'll just give here private void DFS. So I'll just consider the parameters here as bold. So I'll just go with R and C, row and column. So I'll just go with node as well. We need node, node here. This is fine. And we also need the list, which is of the type, which consists of the type string basically. This is fine. So I'll just give here result. So within this one, so I'll just initialize ch to the word of row column rc. This is fine. The first or the base case here is we have to skip if visited or no word path. If we do not have any word path, or if the cell is already visited, then we have to skip in that case, right? So let's write the simple if condition for that. So if ch equals already visited, we'll be considering hash for already visited, or if there is no word path, means I can just write in this way, right? Node dot children here, this one ch hyphen a is equal to null. Then this means that no word path is found here. This one node dot children of ch hyphen a equals null. So then we don't have to return anything in that case, right? So here I'll just give return. We shouldn't return anything. So this is fine. So the next step here is we have to move to the next node in the trie. We have to move to the next node in the trie. So I'll just give here node equals node dot children ch hyphen a. This is fine. Hope this is clear. The next step is if the word is found, then we have to add that word to the result, and also we have to make sure that we are avoiding the duplicates, right? So let's write the simple if condition here. If node, so if node dot word, right? So if it is not equal to null, then we have to, means if full word is found, then we have to add that one to the result, and we have to make sure to avoid the duplicates as well. Let's add the word to the result if the word is found. I'll just make use of the property add here, result dot add of node dot word. Then we have to make sure that we have to avoid the duplicates, means node dot word equals null. This is fine. I hope this is clear, simple to understand, right? So the next step here is we have to mark each cell after visiting each cell. We have to mark that cell as visited. That's what we did, if you remember the approach. So I'll just go with here word of r c. This one I'll just give hash. Make sure that we have marked the cell as visited after visiting the particular cell. So then let's explore all the 4 directions. We have to explore all the 4 directions, one at a time, right? So one step at a time, right? Either we can move left, right, up or down, one step at a time, right? So I'll just give here int. I'll just give the full word directions here. This is fine. So I'll just go with all the 4 directions here. Let me go with 0, 0. Sorry, this has to be basically 0, 1. 0, 1, 1, 0, 0, -1, and -1, 0. -1 vertically, right, up and down. So this is fine. Right down, left, up. Sorry, this is for right down, up and left. This is fine. So the next step here, let's go with the iteration quickly. So here we are going with iterative approach, right? DFS with iteration. So here I'll just go with directions. This is fine. So I'll just assign nr to r plus dir of 0 and nc equals, let me give column c plus dir of 1. This is fine. So let's write the simple if condition. Means if we have found this one, if we have performed DFS and if we have found this one valid in all the directions, right? So for that one, let's write the simple if condition. If nr greater than or equal to 0 and nr less than length of the board here, and also nc greater than or equal to 0 and also nc less than board of 0 dot length. So this is DFS of what means we DFS on all valid directions. So we have to perform DFS on all valid directions. So the parameters that we have here is board, nr, nc, node, and result. We know this one, right? So let's give the same thing here: board, nr, nc, node, as well as the result. So this is fine. So the final step is we have to backtrack. We have to backtrack, right? So I'll just come here in this case, board of RC. So in this case, I'll assign this one to the CH. Means we have to backtrack in this case. Let me come out of here. So let me format this one once. This is fine. Let me come out of this one. The next step is, so we'll be going with we have to build the try, right? So I had shown this one by considering each each word that was present in the words array, right? So we have to build the try as well. So let me go with here. Sorry, where am I to be? So let me come out of here. Let me do one thing here. So this one I have typed wrong here. Okay, it has to. So this is fine. We have successfully written the DFS here. So DFS function here. So let's make use of this one in the main function before building the try. Let's do that thing first. Right here in this case, we are checking if the current letter is start of any word here, right? If it is, then we have to perform the DFS search here in this case, line number 14, right? So here I'll just go with DFS of board, comma R, comma C, and we are going with root as well as result as parameters. This is fine. So finally here in this case, we have to return result, right? So I'll just go with return result. So we are done with the main function, but one more thing here we have to observe, we haven't built try, right? So we have to build the try at any cost. So let's build the try very quickly. So I'll just go with private try node here, build try of string, this one, words. I'll just consider the words as parameter here in this case. So first step here, I'll just go with try node. Let's create the new try node. So I'll just go with new try node. Let's type this one quickly. I'll just go with the iteration here. Let's consider the individual word of strings. Let's consider the individual word from the words. So which is of the type string basically. So word, this one is of from the words array. Basically we are considering individual word from the words array. This is fine. So let's assign node to root here. So we have to we are considering individual characters from the word. So individual characters we are considering from word. This one I'm speaking of. So suppose if we have found oath, we have to consider each character from this particular word, OATH, right? So for that one, so I'll just go with here ch. So I'll just give your word dot to char array. So this is fine. So int, I'll just give here index equals ch hyphen. So we are storing this one in the within the index, right? So we have 26 letters basically. So what am I doing here? This one has to be within the string. We have 26 characters. So that is the reason I have mentioned here ch hyphen, right? We are storing the index for the this one, index of the particular letter or particular character here in this case. So we have to create node if it is missing. For that, let's write the simple if condition here. If node dot children here index, if this is null, means if node is not present, then we have to create that node. When we have, then we have to create the node. So how can we create the node here? Here in this case, node dot children of index. So just give me a second here. Index, this one. For creating, I'll just make use of new try node. This is fine, simple, right? So the next step here is we have to move to the next node, right? So I can just give here node equals node dot children of index. This is fine. After this step, we have to store the word at last character node. We have discussed this one multiple times during the approach. So I'll just give here node dot word. Let me assign this one to the word. Means we are storing the word at last character node. Finally, we have to return root. Finally, we have to return root, right? So this is it for the code. I have done somewhere wrong. I don't know where I have done wrong, but I'm having the feeling I have done somewhere wrong. So just give me a second. So let's do one thing. Let's run the code. So I have a feeling that I have done wrong. I don't know. Let's see. So we have here error expected semicolon, line number 28. Let's come to line number 28. Let me give semicolon here. 44. What we have here? Parenthesis or this one square bracket expected. Where line number 44 here. What did I miss here? New try node I have given here. So yeah, parenthesis I have to give here for this one. So yeah, this is fine. Let me hit the run button again. So try node equals children. Class solution cannot find the symbol. So we are getting here this one, right? Cannot find the symbol. So I think we have to mention this one within this one. So I'll just come here. Let me give static class try node here. This is fine. So let me close this one. Let me close this one. String word I have assigned this one to the null. This is fine. So let me hit the run button now. I hope this works. Let's see. Still have error here. Oh, this T has to be capital T. Try node. Again here, what we have in the line number 10, build tree. Cannot find the symbol. What's wrong here? Method build tree of string class solution. So this one is basically build try. So we are making use of this function, whatever we have built here. We are made use of the build try, right? So this one has to be build try, not the build tree here. So we are making the same function using the same function here, right? So this has to be build try. Board, I have misspelled the board. Let me come to the line number 34. So many typos. So try node error, cannot find the symbol. Again, somewhere I have done the wrong thing. Line number 47. So I have mentioned that node here, I have not mentioned the variable. Wow. So here I'll just give a root in this case. I don't know how many mistakes I have done. Let's see, let's check. So finally, the sample test cases are getting passed. So let me hit the submit button. I hope this works for all the test cases. Let's see. I hope. Finally, yeah, you can clearly see here all the test cases are getting passed. Means the code works absolutely correct on this case, right? So let's quickly discuss the complexities for the code that we have written, right? So the approach that we went with here is try plus DFS. We know this one, try with DFS means try plus DFS with backtracking. Sorry, right? So what would be the overall time complexity here? We have made use of the building try, this one build try function, basically which is of the which holds the time complexity big of L. So L stands for the total length of all the words, right? We know this one. So DFS traversal basically takes big of m into n, as we are going with a grid, right? So it would be big of m into n into 4 to the power of L, right? So L is, we know L is maximum word length, where m into n is nothing but the board size or the grid size. But we are pruning via try, means we are reducing the actual cost significantly. So overall time complexity here, it would be big O of m into n into 4 to the power of L, right? So now we know that the time complexity for the code that you have written is big of m into n into 4 to the power of L. So what would be the space complexity here? Overall space complexity be big O of 1 in this case. So how it is 1 in size? Big of 1 here, because try storage, we are making use of the try. We know this one. Basically, try storage, the space complexity for the try storage is big of L. Means each word here contributes to the nodes, right? So overall space complexity would be for the try storage would be big of L. And also we are making use of the DFS or DFS stack, right? Which is of the space complexity, which holds the space complexity big of L, means maximum depth we are considering, right? In this case, maximum depth during the search, which would be big of L. So try storage big of L, DFS stack big of L, and also we are only we are visiting each cell once, right? And we are marking that cell as visited. We are visiting each cell and we are marking the each cell as visited. In the worst case, we might this one, what do we call? We might explore all the cells, right? And we might explore all the cells, but we are modifying in place. Means hash we are making use of, right? Hash means we are marking that particular cell as visited after we visit that cell, right? So no extra space is being used here. So overall space complexity would be because 1 in this case, right? So space complexity. So the time complexity for the code that we have written as big of m into n into 4 to the power of L, and the space complexity would be big of 1 for the code that we have written, right? So I hope the complexities are completely clear, and I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.